G'day there, you're watching the Aussie BIM Guru, and today we're going to look at how to process clash detection reports from Navisworks into Revit using Dynamo. So I'd like to thank Jose for actually giving me the idea for this script. He's currently working on his own version that I gave him some pointers on. So I thought it'd be great to sort of share my take on the workflow, and it'll be good to see how he goes with it as well. I've actually shared like a teaser of this on LinkedIn, which was quite popular. It got almost 300 reactions so far in just over a few days. So I think there'll be a lot of people that hopefully will enjoy seeing how this is actually put together and works. So the workflow essentially is we're going to take a Navisworks clash test. We're going to generate a standard XML report, and we're going to convert that into an Excel file. And then we're going to read that file using Dynamo in order to place markers at those coordinates. And placing them at the coordinates isn't as easy as it sounds, because we're going to need to process Dynamo coordinates into Revit coordinates by reading some of the base points of the model. So you'll get to learn a little bit about rotating coordinate systems as well, which is quite a common workflow when you're using Dynamo for interoperability. So why would we do this instead of just using Navisworks or something like BIMtrack or Revitso? So we're using this because this allows us to let our Revit users operate with Navisworks clashes without needing to know how Navisworks really works. And only Navisworks Manage has the ability to view the clashes natively. And typically this is only packaged in the AEC collection as Simulate, which doesn't actually let you view the clash detective, only the report. So this is a way to bridge that gap. And as a result, it's also quicker than using Navisworks Switchback, which requires you to keep jumping between the programs every time you want to look at a clash in context. And also it's an easier way for users to track whether they've closed out clashes, because they can go through and delete the markers as they go, rather than have to keep marking off an Excel report, which takes a lot longer. So we're going to start basically in Navisworks. I've already pre-generated a clash report, but I'll really quickly show you the method that I used. If anyone's interested in Navisworks for the channel, please let me know in the comments, because I haven't currently covered Navisworks just because there's a lot of tutorials out there, but there's a lot of things I can share if people are interested. From here, we're going to generate a clash report, and it's important that we're really honing in on this clash point column of our clash report in our Dynamo processing. So we're going to use these points to place markers. And from there, we'll place our sphere, and we'll push some parameters into those spheres as well, such as the coordinates that they relate to in Navisworks, their clash name and their status, and also the element IDs of the elements involved in the clash, all of which comes from the clash report in Navisworks. And it's important to note as well that we'll be using Revit filters in order to color the clashes based on their status, which typically in Navisworks is, I think, approved, reviewed, new, and I think ongoing or active, I believe it is. So we'll be using that system as well. We're going to be using two custom nodes today, only two, so quite surprising. We're going to be using the Get Worksheet Names node from Bumblebee. You could also use the one from Archilab, which works similarly, and also the Get Project Locations node from the Genius Loci package, which will allow us to read the coordinates in Dynamo of the project location and base point, as well as true north rotation. And ideally, if you use something like 2.0.3, because that's the last build I've been testing on. I'm not sure if this works in 2.1, it probably does. And again, 1.3 and those sort of versions, not sure if it works either. So without further ado, let's just jump into it. So I'm just going to jump straight into Revit. So it's important to note I'm using the Autodesk sample projects. These are available for anyone with access to Autodesk Revit. Essentially, they should be in a little folder in your C drive or wherever you install to. And there should be a folder called samples, and you'll have a whole bunch of models. So what I've used to generate this one is the mechanical advanced sample project for services and the structure advanced sample project for structure. Because we're going to be clashing beams against ducts. Well, I have clashed beams against ducts. And what I've done in both models before I've generated Navisworks files is I've placed the project base point on this grid intersection in both files and set its coordinates as such. So north-south at 110,000 millimeters and east-west to 80,000 with a true north rotation at 15 degrees. Just so we're working at a more typical coordinate system than we would in the sample files as they come. And then our survey point is just placed all the way over here at 0, 0, 0, which is more common practice. The internal Revit origin is somewhere around here. It's basically just where the model was started from, and it's very common for these not to be in the same location as the project base point or the survey point. So we're going to work around this using Dynamo as well. Anyway, so over in Navisworks, I've actually generated a clash test. So I've clashed two search sets. I've taken the roof beams and I've taken all the ducts in the project and just done a hard clash just to find all the clashes between those elements. And then I've just placed them all in a group so I can see them together when I select them. And that's pretty much all the clash involved elements. And every one of these clashes has a point related to it. So what I've done is generated a HTML tabular report of these elements. So essentially an HTML tabular report looks a little bit like this. So it's got rows and each row is a clash. And you can see it's storing a lot of information. So things that we'll be leveraging, for example, the element IDs, the location, we'll be looking at the status, the name, but you could look at other things too, like the date found, probably comments. So if you want to push all this stuff in for using Dynamo, feel free to. Today I'm just going to focus on a few fields. But what I've done then is just opened it up in Excel. I've kept the structure exactly the same, and it's important to note that the first tab is typically named after the name of the clash test. So we're going to have to use Dynamo to figure out the name of the first worksheet. So let's just get started in Dynamo, in Revit actually, and we'll just boot up Dynamo. So I'll just go on 2.0.3 and we'll get started. So we're going to begin by processing our Excel file. It's important to note that we're pretty much going to be ignoring the first more or less the first 7 rows of our table, because these pretty much have nothing of value in them. All we care about from there is our header row and our data. So we're going to have to do a bit of filtering and processing of our table in order to hone down to the data we care about. So I'm just going to open a new script. So the first thing we'll do is we'll get a import Excel node. So we need to get a file path and a file from path in order to path to our Excel file. So I'll path to the clash report in Excel. I'll get a file from path and I'll place that into the file node. And for the worksheet name, we're going to use that node from Bumblebee. So I'll just look for worksheet names and we'll just go to Archilab Bumblebee. And we'll just take our file path, we'll get a boolean to run it, and we'll set it to true. I'm in manual mode currently, and we're just going to get the first worksheet, just in case there's more than one tab. So this way a user can run it over a clash report without having to do any modification to the Excel file. So I'm just going to go x square bracket 0 to get the first item in that list of worksheets, just in case there's multiple tabs, and put that in as the sheet name. For reader strings, I'll say true, and for show Excel, I'll say false. So I'll just put those two into a code block as such. Okay, so at that point, if I run my script, I should get all of my data from Excel. And it'll be a lot of nulls, which are basically blank cells. So for example, those first 7 rows are mostly null. So the first thing that I'm going to do is actually drop the first 8 items of my table, or the first 8 rows. So I'm going to get a list, drop items, and I'm going to drop 8 things. This way, our first row that we get information from is going to be the row below our header. There's still some nulls for things such as the image column that we'll need to process out as well. But what I want to do then is I want to get the header row as a separate one. So I'm just going to call on x7 or index 7 to isolate our list. So I'll just run this. And now you can see we've got our header row just on its own. You can see as well that the clash report goes quite far along. So you will have to be careful with that as well, because it does count data out here, even though there's nothing populated in it. It's just the behavior of the Excel node. If a cell has been formatted at all, Dynamo will consider it. So we just have to be careful with that. So we're just going to do a big code block here actually. So I'm just going to start writing out some functions. So I'm going to do dscore.list. I find it frustrating how the list jumps to date time. We're going to get an index of, and we're going to call on the headers as a variable, and we're going to look for the index that clash name occurs at. The reason we're doing this is because the clash name might not always be in the same column, because maybe users will export more fields or less. What we're going to do then is just, we'll start copying this row actually, because we're just going to do this a few times. So we're looking for clash name, we'll look for status. And each of these rows essentially will give us one index. We'll get clash point, which is the location of the clash. And then we'll also get the element ID. But what we'll do in this case is we'll set the ID as a variable because there's two element IDs in the clash report. So we'll get the first one and we're going to find the first index of item ID. The reason we're doing this is because there's two columns with the same header in this report, but it's always next to the next one. So I'm basically looking for this column, but note that there's two called item ID. So the way that index finding works in Dynamo is it will find the first match. So what we need to do from there is just add one to the index of that one that we find. And that way we know we're dealing with the next column. So we can say that ID2 equals ID1 plus 1. And then we'll feed in our header row. And essentially this should give us our individual indexes of each header. So for example, I can check that my clash name index is 2. And we can validate that in our table as well, obviously, by going in and checking the column. And we can see that in this case, clash name is occurring at index 2 because it actually puts the first column in 2 columns instead of 1. So the image takes up 2 columns with a merged cell. So technically this is index 3 or 2 and 3 in the columns of the table. But index 3 is technically empty, it's just a merged column. All right, so we've got our indexes. The next thing we need to do now is we're going to drop the last row of our table. So we're going to drop by a factor of -1, which basically means go to the end of the data set and take off the last one. So you can use negative to work the other way. And the reason we're doing that is because at the back of our list, down the bottom in Excel, there's actually a blank row that gives us a whole set of nulls. So we need to get rid of that. Okay, and what we're going to do now is transpose our data so that our columns and our rows flip in our list structure. And we're going to have to actually start calling on the getItemAtIndex function or the indexing function using these indices over this data set. So let's just use a code block and I'll just say names equals list1, status equals list. And what I actually need to do is call these variables. So I'll do index2, so I2. I'll go back and do I1. And as you can probably guess, we're going to be using those indices that we called on previously up in this code block over here. And this essentially just means that the user doesn't have to rely on the table being sorted in any particular order in Excel. We can use Dynamo to always make sure that we're finding the matching indices of that table. Okay, so we'll do I4 for the ID2, also ID1, and ID2 we'll do at list I5. So we should end up with a variable for each index and also a variable for the list. So the list is the transposed data, and then each of these will be the index of that respective piece of data. So what I actually need to do, is connect these all up one by one. And we can just check what we get using a watch node. So let's just check the point in this case. Cool, and you can see now we have a list of all our points and we have 69 elements. Let's check the status as well, just to make sure we're getting equal list links, and we do, we have 69. And you can see it's all coming through. So now we have all this data parallel, we can carry on with to the next stage. But the first thing we're going to do is actually turn these points into actual points, because currently this is a string made up of some letters. So we're going to be using a string split in order to get the numbers that come out of this string, because that's just one string essentially. So we're going to separate by a few things. So we're going to add 3 separators. Our first separator is going to be x semicolon space. And our second separator will be comma, y semicolon, that's lowercase y, semicolon, and then our last separator will be comma, z, semicolon. And the reason we're doing that is because these essentially are what are separating our numbers from each other. So you can see we have that X semicolon space, comma, space, Y semicolon, comma, space, Z semicolon. So what this should do is actually break our strings into pieces. So I'll just run that. And now you can see we end up with a sublist. I think I've made a capital there. Oh no, I just need to make sure this one's actually working. Interesting. It looks like I might have made a typo. I think there's no space there. I think that's why. There we go. So now we have a sublist with the X, Y, and Z of each point. So what we need to do now is convert these to numbers because they're still strings at the moment. So we're going to use a string to number. And this will convert all the strings, keeping the list structure intact as well. So now it looks like the same list, but it's technically not. Now we're dealing with real numbers. And we're going to convert as well because these are currently in meters, whereas we want these to be in millimeters. So we're going to use a convert between units, and we're going to feed in length, and we're going to go from meters to millimeters. So that's my native unit. Cool, and you'll see this should convert all of them. So we can see the decimal place is moved by 3. Which is correct. And what we need to do now is transpose these so that we get a list of all the X points, all the Y points, and all the Z points. So we'll transpose our list. And the reason we're doing that is so we can feed these into 3 lists. So at the moment, we should end up with a list of all the X points, a list of all the Y points, and a list of all the Z points. So let's just call on a code block at this point. And I'll say X is equal to the index 0 of this list, Y is equal to index 1, Z is equal to index 2. You might notice I'm using code blocks a bit more. I am trying to integrate them into my workflows more often because I have had users request more about these. Okay, so what we could do at this point is simply just do a point by coordinates. And this is where it's going to get a bit challenging because you might expect that these are all just going to be in the right point already, but you would be wrong. So if I just go back to my Revit model and I'll just jump into 3D, make sure I'm actually working upon the right Revit model, which I am. I might just close the mechanical model, which I have open on the side. This is the mechanical model that I've taken all those ducts into Navisworks from, but we're going to work within the structural model so that we can see the location of all the mechanical clashes on the beams. Alright, so we'll just reopen that. Dynamo is available. Okay, it looks like it was actually on the mechanical model, so it's good that we've actually closed that one. Because you always need to make sure that you know which active document Dynamo is pointing to. The easiest way is to close everything except for one thing. Okay, so we're just going to run this, and we get a whole set of points. But look at this, it's in the wrong spot. So it's actually not factoring in the rotation to true north, and also not factoring them in the coordinate system as well. So this is a problem. So what we need to do is convert Dynamo coordinates from real world coordinates. So you may recall before that I was mentioning that I've already set the project base point and the survey point. So we're going to use the project base point in order to translocate the Dynamo coordinates. So it gets a little bit tricky, but bear with me and we'll get there. So the first thing we're going to do is we're going to define the Dynamo world coordinate system. So we're just going to get plane to coordinate system. And we're going to use the local XY plane in order to define the Dynamo coordinate system. And the reason we're doing this is because we're going to rotate the coordinate system and we're going to move it as well by a vector. What we need to do now is we're probably going to just get the project location. So this is that Genius Loci node that lets us get the data about the project location points. So we'll do get project locations, and I will just run this once. So what this will give me is it will give me the coordinates of the internal Revit origin, which is currently also the Dynamo origin, but it also gives me the rotation to true north and also the XY location of the project base point. So we can use both of these in order to figure out how far away our Dynamo coordinate system is from our local coordinate system in Revit. So what we'll do now is we'll just take the project base point rotation, which is at index, I think it's at index 3 of the project base point list, which it is. So I'm just going to go project base point equals, actually I'll just say project base point index 3. I'll just refer to it without a variable. And I'm just going to take the project base point, run this, and I should get a number, which in this case is 15, which is correct. So that's my rotation to true north. So the first thing we can do now is go coordinate system, rotate. We're going to pick origin axis degrees as our method of rotation. So we're going to take the Dynamo coordinate system that we've already defined, and we're going to take the origin by getting the origin point in Dynamo as the origin point, and around that point we're going to rotate by 15 degrees, and the axis will be Z. So we're taking the axis that points up and rotating around that. So I'll just take that axis, and you won't really see any difference at this point, but essentially we've rotated the world in Dynamo by the angle to true north. So that's a good start. But the next thing we're going to need to do is actually, we're going to translate our coordinate system as well. So we're going to get translate coordinate system. And we're going to do it by direction and distance. So as you can guess, we're going to be moving this coordinate system, but we're going to be doing it by a direction and a distance. So what we need to do now, I might just disconnect that temporarily. I'm just going to make a code block, and I'm going to say that the north-south displacement is going to equal the internal origin, and this will be index 1 in its list of coordinates for the north-south component. But we're going to do times -1 because we have to move back by that distance in order to transpose our coordinates, because we're essentially moving Dynamo back to the right position in our model. So we have to take those away. So we're going to do the east-west displacement is equal to the internal origin list, and we're going to do index 0 for this one, for the east-west, times -1. I'll just double check. It looks like I must have forgot a semicolon. Yep, there we go. And we'll feed in our internal origin list, and this will give us our translations for north, south, and east, west, respectively. What we need to do now is find that point in Dynamo currently. So we're going to use point by Cartesian coordinates. And this allows us to define our coordinate system and then define our coordinates. So we're going to take our coordinate system and we'll take our X and our Y. So in this case, our X will be our bottom row, or our east-west, and our Y will be our north-south. If your project did have elevation differences between project base point, survey point, and internal origin, you may need to deal with Z as well. In this case, I don't, so I'll skip over that, but it's the same logic. You just need to find the difference between Dynamo and Revit. So what we'll do now is just get the origin again, and we need to find a vector between these 2 points in order to find the distance that our coordinate systems are apart by. So the first thing we'll do is get a vector by 2 points. And our start point will be the origin of Dynamo, and our end point will be the actual point in Revit itself that we want to move to, so that we get that translation vector. We also want to find out how far we need to move by. So I'm going to get a distance, and I'll just use the distance too. So we're going to say how far is it from that point to this point. We're going to say that we want to move this coordinate system, and of course we're going to move it in the direction of that vector by that distance. And again, you won't really see anything at this point, but you will see, I think we need to change our geometry scaling settings under settings. We'll just go to extra large. I find that in most projects you need to enable extra large typically. So this will give us a coordinate system that is aligned between Dynamo and Revit. You can see the sort of the markers here in my geometry display. So what we can do now is actually establish points by Cartesian coordinates instead of by X, Y, Z like we did before. So I'm just going to create point by Cartesian coordinates instead of point by X, Y, Z. And using this coordinate system and deleting this point by coordinates, we'll create points at X, Y, Z in this coordinate system. So now we should get them in the right position. So we can really quickly test that by just doing a quick run. And there you go. You can see that we've corrected the difference between Dynamo and Revit's coordinate system. So quite complicated, but a really handy workflow to know when you're working between Navisworks and other similar programs that use a different coordinate system to Dynamo, which is pretty much nearly every program, because Dynamo has its own internal origin system. Okay, so from here, essentially really what we're going to do is place families at these points and set some parameter values. So we're going to do adaptive component by points. And it's going to be 1 point, and we also need to get a family type as well. So what I've actually built on the side here is a special family. So essentially all this family is a adaptive sphere, which is generated from a profile. So if I dissolve this, you'll see that all I've done is I've done a revolve just around the origin point, and then I've made the center point an adaptive point. What I've also done is added some shared parameters to this. The only ones that you will need to add from your shared parameter file are any of the following things you want to report. So I've picked here, for example, X, Y, and Z as numbers, and I've also picked the clash name, status, and IDs as text. It's up to you what you want to use. I recommend you use status at least, because we're going to filter by status. So that's quite important. If you're not sure how to set up this family, let me know. I'm happy to send you a demonstration version of this family to help you along. But what we're going to do now is just load this into our project. And this is the family we're going to place using our script. But we're also going to set some parameters of that family as well. Okay, so we're going to get that clash sphere, as I've called it. And essentially this is the family we're going to place. So I'll just actually run this without setting parameters first, just to show you that this part works. So I'll just sort of zoom out so you can see what I'm seeing. So we're in 3D. And I'll just open up Dynamo on the side. Cool. And we'll make sure that we've set our adaptive component to longest lacing as well, so that it applies every family to every point. We'll run, and it should place a sphere at each of those points. And there you go. You can see it has, so really powerful, but obviously we need to add some information to these. So I'm just going to undo that step. I'm going to save, and I'm just going to close my script and reopen it, just to refresh the placement of that geometry. Okay, so what I'll do is just freeze the adaptive components by point. So what we need to do now is do just a little bit of processing and then some set parameter value by names. So we're just going to get a set parameter by name. And we're going to be doing 5 of these. We're going to set them all to longest lacing. And I'll just get a string for each one for the parameter name. The element is going to be our adaptive components, and the values will be their respective list of values from back here. So let's just start off with name as an example. So we'll just move these a little bit out of the way. So this one will use my shared parameter, which is crn underscore clash underscore name1. So this is the name field, and noting it's an instance parameter, that's quite important as well. We're going to get clash status as well. This is a text parameter, another instance parameter. I'll just reconnect that back to the status list. Point, we've actually broken up into 3 parameters, so I'll do that one separately. The next one we'll do is the first ID. So we'll just go current clash ID1 and also ID2. So we're going to process the ID1 and ID2 fields just a little bit because they don't quite have the structure that we want them to have. So if we go back and just double check what these ID1 and ID2 ones look like, they're not quite what we're after. If I run this, you'll see that we have a few letters on the front. So we have element ID, semicolon, space, and then the ID. We actually want to drop those characters. So this is basically the first I think 12 characters of the string. So what we want to do is take that string, and then starting from index 0, we want to remove 12 characters. So that all we're left with is the number. And there you go. Now you can see we just have the IDs as text. So we're going to get 2 of these with the same input for the indexes. So we'll get ID1 and ID2. Okay, so this will essentially be our input parameters. So we'll just move these over here back to our ID1 and our ID2 fields, and then connect the outputs to the values. Cool, so we're setting our IDs, our status, and our name. The last things we'll set are just the X, Y, Z points, which are quite easy. We'll just take one of these set parameters from up here, move it down here, and I've just created a number called Chrome Clash X, Y, and Z. So as you can guess, I'm just going to create 3 of those, essentially, and just set the Y and Z values as well. So once these are created, all the parameters will be populated to match the Excel document as well. Cool. So I'll just take the X, the Y, and the Z. So at this point, we're ready to place them, and we're also ready to set the parameters. So I'm just going to save, I'm going to run, and it should place all these families and set their parameters as well. Shouldn't take too long. Cool. So that should be done. So now we should be able to expect to see a whole bunch of those clash spheres. And we should also be able to see all their information populated as well. So you can see that our X, Y, Z points are in as numbers, and our name, status, and ID 1 and 2 are in as well. So what I'll do now is just create a little section box around my view. And I'll just do temporary hide isolate, and I'll just set up some graphics. So we'll just go halftone transparency at 100, and we'll just take that off of generic models. We'll override our generic models using filters. So you could just use that for your clash points right now if it was easier. What I'm going to do is just add some of those shape parameters to my project so that I can apply filters based on them. I'll just do the active status of the clash. So we're just going to put that on generic models as an instance parameter that can vary by group instance. Okay, so we'll just create some filters. So I'll just create a rule-based filter, and I'll just call this active. And we want to filter any generic models whose clash status equals active. And likewise, we want to duplicate this filter, and we'll get one for reviewed. Just modify this one to actually, we'll do, I think reviewed is one as well. Yeah. And then we want approved and resolved. Cool. And then resolved. These are basically our classes of clash, aside from new, which wasn't in my clash report. Resolved. Okay, so we got resolved, reviewed, approved, and active. So we'll just add these filters under filters, and we'll just add active, approved, resolved, reviewed. I do like to add an additional filter just to control the line style of all the sensors. So I'll just call this clash spheres. And I'll apply this to generic models, and I'll check that the family name is equal to clash sphere. And I'll add this one on top, just because filters work in a top-down hierarchy. And for this one, I'll just say that the lines are, we'll just say that they're gray, and that should do. Okay, so we're just going to override our active with the color orange, and we'll make that solid. And we'll make it transparency at 50%. Reviewed, we'll put at, I believe reviewed is, I think it's green. If you're not sure on the colors of them in Navisworks, feel free to just jump into Navisworks and have a look. So reviewed is blue. It's good to probably match these so that people that use Navisworks understand what they're looking at. So we'll make that cyan. And we'll make that 50%. Approved, in this case, will be, I believe approved is yellow. No, approved is green. I think, yeah, resolved is yellow. So we'll just make that green, lime green, 50%, and resolved, we'll make yellow. And we'll make that solid and 50%. So now, depending on the class of clash, we should get different colors. So it's really easy to sort of see what statuses of clash are occurring in which area. And if you want, you can always filter certain categories off. Let's say we only want to look at active clashes. So I can just turn them off in filters, and now we just see our active clashes. And it's really easy to go and cross-check where a clash is in Navisworks as well. So let's have a look at this one. So because I've pushed in the clash name, I can see this is clash 351. So if I go back into Navisworks, and I go back into my results, and I look for clash 351, just to cross-check. And there you go, you can see that is, in fact, the clash that we're looking at. So you can see that our workflows work successfully. So pretty exciting. And there's obviously a lot more you can do with this workflow. There's other ways you can process the clash report. You could use a different sort of family. You might be able to generate views for each clash. Lots of options. So really just see this as the tip of the iceberg of a more complex workflow. So hopefully that's helpful. So thanks for watching. Thanks for those that actually stuck around for the whole thing. I know it's quite a long workflow, but hopefully it helped you. So feel free to leave any comments or recommendations or questions down below if you have any. And again, if you want to learn Navisworks on the channel, let me know, because I do know Navisworks quite well. I just haven't created the series for it yet, and I'm more than happy to. So I make videos about 2 to 3 times a week, if you're not following already. And if you're not already subscribed, feel free to do so. And hopefully I'll see you in the next video. Thanks. Take care.